Look at this. We have a circle with center 10, 6 and an external point 2, 3. So our task is here drawing two tangents from this external point to the given circle with center 10, 6. Let's do this practically and theoretically, both. For this, I'm using Desmos for the graph. So here I'm about to fix a point first. So external point is x1, y1. So I'll take x1 as 2 and y1 as 3. I'm done with the point. Let me just show it in the graph. So let me label that. So here the point 2, 3, right? We just labeled it and we have shown in the graph. Next, we have center of the circle x0, 10 and y0, 6. So let us even mark this on the graph. x0, y0. Let's label these two. So now we have 2 points. One is external point 2, 3, external point to the circle. Okay, and here another point which is the center of the circle which we are going to draw 10, 6, and we need radius for that. So let me take radius here. R is equals to some 3. I've taken radius is 3, but immediately once you have taken radius is 3, it automatically created a circle with center 0, 0, like center as origin. But I don't want circle there. I want this circle with the center 10, 6. Let me shift there. How I can do that? We have circle equation x minus x0 whole square plus y minus y0 whole square is equals to r square. We have r anyways, r square. I don't want the circle, I just remove it. So this is it. Now we have got circle with center 10, 6 and external point 2, 3. Our task is to draw two tangent lines to the circle from this external point. For that we need certain equation because both are line equations. So we need two different line equations which pass through 2, 3 and touch the circle at two different points. Okay, so for that, one is for this what I'm going to do is I'll just find slope. If I find the slope of that particular line equation, and I have already point here, so point slope form I can use here. So y minus y1 is equals to two slopes, because we want two tangents, two different different slopes. So m1 is one slope, x minus x1. So this is one equation, but here we have not defined m1 and m2. Let me first define them. m1 is equals to, simply I am just taking 0 here, and another m2 also I want. So m2 is also 0 I have taken here for now temporarily. And then now y minus y1 is equals to m1 times x minus x1 is one line equation. The other line equation is y minus y1 is equals to m2 times x minus x1. All right. So both have blue lines. I'll just modify again. Y minus y1 is m2 times x minus x1. Okay. So now you don't see two different lines immediately because both slopes we have taken 0. So when m1 and m2 0, this becomes y is equals to y1. This also y is equals to y1. What is y1? 3. So y is equals to 3. So this is parallel to x-axis. So therefore the green line has two different lines. Okay. One is with slope m1 and one is with slope m2. Because we have defined m1 and m2 both as zeros. So let me think of it. What values of m1 and m2 so that the lines exactly touch the circle at two different points. Anyways, one line is meeting the circle at one point. The other line we want, which is not having the slope 0. So for that we calculated, we have a value, we'll just calculate that as well, 48 by 55. So I have just defined m1 and m2 here now. So this is the line equation with slope m1 which is 0, and this is another line equation with the slope m2 which is 48 by 55. So these two lines, if you see, these two both meet at point 2, 3 external point and meet circle at two different points. So these two act as tangents. How to find slopes, the derivation, everything we'll just now do, followed by another task for you. Okay. We have a circle with center x0, y0. O x0, y0. And I'm taking a point, maybe some a, x1, y1. Now our task is to draw tangents to the circle. Okay, from external point a to the circle with center x0, y0. So this is one, it should meet actually. This is another tangent. So these are two different tangents drawn from external point A to the circle with center O. So AP and AQ are two tangents. Now we know point of this line. We don't know P. If we know P, we have 2 points formed, we can directly get the equation of that line. But we are not going to find P and Q here. Instead, we just need slope of this line and slope of this line. So therefore, you have a point and you'll get maybe slope for AP is m1 and slope for slope is equals to m1 for AP, and here slope is m2. If you get m1 and m2 slopes of two different lines and you have a common point, you can get the line equation. Point slope form we have point slope form. What is point slope form? Y minus y1 is m times x minus x1. So this is point slope form of a straight line equation. Okay, so now we have x1, y1 and we have two different slopes. So equation of AP is y minus y1 is m1 times x minus x1. If you get slope of this AP, and you'll get the slope of, equation of AP as well. Similarly, equation of AQ is y minus y1 is m2 times x minus x1. So here we have same point. That's why we have taken x1 and y1, x1 and y1 in both equations, but only slopes differ. Okay, so this is what it is. How to find m1 and m2 is our major part here. Let us try to find m1 and m2. Just observe one thing. Suppose this is circle with center O, and this is a tangent line equation, and this is point of contact P. This tangent may be I'll take it as T tangent. Okay. Now this is perpendicular to tangent. So radius perpendicular to tangent, we know, at point of contact. So now the same thing, let's understand OE is taken as just a point x0, y0, and this is a line equation, same line equation T. Okay, here it acts as a tangent, but here it is just considered as a line. So this is the perpendicular distance. Now OP is the perpendicular distance, so D. Now in these two cases, what you can conclude, R is equals to D. If you draw a perpendicular to AQ at Q, the distance, perpendicular distance from O to Q should be equals to radius of the circle. So that is what it is. By that, we are going to get M1 and M2. Okay. So this much is clear, I hope. Okay. So now we discuss the perpendicular distance formula. So O, x0, y0. And this is perpendicular distance D to the line equation T. This line equation we have already got, right? Like y minus y1 is equals to m times x minus x1. Correct? So this is the line equation now. Let me just convert into ax plus by plus c form. Like y minus y1 is equals to mx minus mx1. I'll transfer everything to RHS. Mx minus y plus y1 minus mx1 is equals to 0. It's in the form of ax plus by plus c is equals to 0. Here, what is a? M. What is b? Minus 1. And c? y1 minus mx1. So we have got a line equation and we have the point. We know perpendicular distance formula. Perpendicular distance from a point P to the line. From a point P or maybe whatever point to the line is D is given by under modulus A x1, that point to be substituted. X1 is x0 here, A x1 plus B y1 which is y0 plus C by square root of A square plus B square. So this is the perpendicular distance from a point to the line. Okay. Now we know this perpendicular distance is nothing but radius. So can I equate it to radius R? Okay. So now we are going to simplify this. Take squaring on both the sides. From this squaring on both the sides, what do we get? A x0 plus b y0 plus c whole square is equals to r square times a square plus b square. Now I replace a, b, c values. A is m, mx0 plus b is minus 1 times y0 plus c is y1 minus mx1 whole square is equals to r square times a square plus b square. Correct? So now let me just simplify this. Mx0 minus y0 plus y1 minus mx1 whole square is equals to r square times a square plus b square. M times x0 minus x1 plus y1 minus y0 whole square is equals to r square times a square plus b square. Now let me expand it. A plus b whole square form. A square plus b square plus 2ab is equals to r square times a square plus b square. So m square times x1 minus x0 whole square, because a minus b whole square is nothing but b minus a whole square, plus y minus y0 whole square. Here I'll take minus out, so minus 2m times x1 minus x0 times y1 minus y0 is equals to r square times a square plus b square. We didn't replace a square plus b square here. We'll replace r square times a square. A square is m square plus b square is minus 1 whole square, which is 1. So let me just further simplify into a quadratic equation in m. Okay, so for that m square I'll take common. So x1 minus x0 whole square minus r square times m square minus 2 times x1 minus x0 y1 minus y0 times m plus y1 minus y0 whole square minus r square is equals to 0. So what you see in this, it is in the form of a quadratic equation in m. Coefficient of m square is something and m is other and constant. So a m square plus b m plus c is equals to 0. Let me take this as pm square plus qm plus r is equals to 0. This is in this form, where p is equals to what? x1 minus x0 whole square minus r square. What is q then? Minus 2 of x1 minus x0 y1 minus y0. What is r? R is y1 minus y0 whole square minus r square. So we have got PQR, and this is a quadratic equation in m. We know how to solve quadratic equation. To find roots of a quadratic equation, we have here m, because variable I am taking is m. So m is equals to minus b plus or minus square root of b square minus 4ac by 2a. So this is the formula. But m value we have two different values. We'll get two different values. First value, which is m1, is minus q plus square root of q square minus 4pr by 2p. And m2 is minus q minus square root of q square minus 4pr upon 2p. So we have got now m1 and m2. Okay, if we get m1 and m2 and we are done, we have equations. What is first equation AP? Equation of AP is y minus y1 is m1 times x minus x1, and equation of AQ, y minus y1 is m2 times x minus x1. All right, yeah. So this is how we'll find m1 and m2. Here external point A is given by 2, 3, and center of the circle x0 y0 given by 10, 6, and the radius r is given by r is equals to r, which is equals to 3 units. Okay, so this is what our sum. Now let's find m1 and m2 here clearly. What is m1? qpr in terms of pqr. We have a p value, q value and r value in terms of x0 and x1 and r, which are known values. So let us find p separately, q separately and r separately, then substitute back in m1 and m2. So p is equals to x1 minus x0. What is x1? 2, x0 is 10. So 2 minus 10 whole square minus r square, which is 3 square. Here it is 8 square, 64 minus 9, 55. So p I have got 55. And q is equals to minus 2 times x1 minus x0, 2 minus 10, so minus 8. And y1 minus y0, which is 3 minus 6, which is minus 3. So we get minus 48. Okay, that is q value. And what is r then? R is equals to y minus y0 whole square, 3 minus 6 whole square, which is minus 3 whole square, 9. Minus radius is 3 square. So which gives 9 minus 9, 0. So r is 0. So we have got p, q, r. Let's substitute here to get m1 and m2. So here m1 is equals to minus q, minus of minus 48, which is plus 48, plus square root of q square, which is minus 48 whole square, minus 4, p value is 55 and r value is 0, by 2 times p is 55. So now what do we get? 48. This is anyway 0. So 48 square minus 0, which is 48 square only, and square and root cut, This can be positive because it is in square. So 48 square I can just write directly. So I'll take plus 48 by 2 into 55. So it is again 48 plus 48 is 2 times 48 by 2 times 55. So 2 to cut, what we get is 48 by 55. What is that? M1. So we have got M1 value now. We have got M1. Now let's find M2. M2 is minus q, which is again minus of minus 48. 48 minus square root of, here it is the same whole square, minus 4 times 55 times 0 by 2 into 55, which is 48 minus this again 0 and 48 square again 48 by 2 into 55. Numerator is anyways 0, 0 by something is 0. So therefore M2 we got 0. So now the same values we substituted there. Like M1 is 48 by 55 and M2 is 0. If you take M1 as 0 and M2 as 48 by 55 also, one are the same because this is one equation, this is one equation. Okay. So through by this we'll get two tangent equations exactly from an external point A to the circle with any center. Okay. Because we have point and we have slopes. Let's find equation of AP and equation of AQ. Equation of AP is y minus y1. What is y1? 3 is m1. m1 is how much? 48 by 55 times x minus x1. This equation acts as one of the tangents. So for that we just need to input only 48 by 55. You don't need to write this completely because this is already given in the Desmos browser, okay, in the graph. Only m1 we need to enter manually and it takes that value and automatically generates the straight line equation. And equation of AQ is y minus 3 is 0 times x minus 2, which is nothing but y minus 3 is 0, y is equals to 3. So another tangent you must get as parallel to x-axis. Okay, it's shown in the graph, right? The same way we'll get a parallel line to x-axis which meets circle at one point, and this is another line equation which meets circle at other point from A. So these two are the tangents drawn from external point A to the circle. You take external point as 7, 7, x1, y1 as 7, 7, and center of the circle as 2, 2. That is x0, y0 as 2, 2. And radius is 1 unit. In this case, it is 3 units, right? There you take as 1 unit and follow the procedure and get M1 and M2. The same M1 and M2 enter in the link given in the pinned comment. The task is points are 7, 7. I'll give you point as 7, 7, which is an external point here, and center is 2, 2. Okay, and radius is 1. So you observe the graph now. You have circle with center 2, 2 and external point 7, 7. From this we need to draw two different tangent equations to this circle. So you do this and comment. I'm sharing this link in the comment section. The pinned comment you can just copy and paste it in your browser like this. And you'll get as it is. Okay. What you need to do is you just need to modify M1 and M2 values. I'm just, for example, telling you, you don't need to disturb the rest all the tabs. You just change M1 and M2. It's sufficient because we just need two different line equations which are tangents to the circle from this external point 7, 7. Okay, I'm just taking here 5 and M2 and minus 1. So if you see clearly, these two lines do not meet circle but still pass through the external point but do not meet the circle. So that's how we need to define their slopes. Then only we can exactly draw the tangents to the circle from this external point. So find out this M1 and M2 by the method what we just discussed. I just make it as 0, 0. Okay. And I share this to you. The same thing I'll share. So this is what it is. The same thing I am going to share to you in the comment section. So copy and try this. Let me know in the comment section whether you get M1 and M2 exact values, so that you can be able to see the tangents in this graph practically. You solve them and then enter M1 and M2 here. That's all. Just M1 and M2 values. You need not to disturb any other tab. Okay. Yeah, that's all. Thank you. By the way, subscribe to RAM Code Logic. Okay. For more interesting videos like this, please support me and we'll keep growing together. Thank you.